our speakers and guests, Chair of Institute for Research and Community Services, ITB, Dr. Yuli Setio Indartono, Executive Secretary for Research of LPPM ITB, Dr. Rino Rahmatamukti, the Deans of Faculty of ITB, Chief Editor of ES&T Engineering, Professor Wonyong Choi, Lecturer in Faculty of Civil and Environmental Engineering, ITB, Dr. Anindrya, Nastiti, and Dr. Windy Iriana, President of the Student Chapter, Ms. Raisa Iza, Market and Business Development Manager from ACS Publication, Ms. Mendisam. Distinguished guests, ladies and gentlemen, today our agenda as follows: opening remarks, presentation by Professor Wonyong Choi, presentation by Dr. Windy Iriana, question and answer panelist discussion, ITB Student Chapter by President of ITB Student Chapter, trivia question from ACS Publication, and the last is closing remark. Firstly, we would like to invite our Chair of Institute for Research and Community Services, ITB, Dr. Yuli Setio Indartono, to present the opening remark. Please welcome Dr. Yuli Setio Indartono.
Yeah, thank you, Bu Karina. Bismillah. Assalamualaikum warahmatullahi wabarakatuh. Respected ladies and gentlemen, mainly Professor Wonyong Choi, Distinguished Professor and Director of Korea Institute of Energy Technology, EANTAGH, Dr. Windy Iriana, our faculty member from the Faculty of Civil and Environment Engineering, Ms. Mandy from ACS Publication Coordinator, Pak Rino, and ladies and gentlemen, this morning we also have a ceremony by virtual talk to commemorate the World Environment Day. When I check in the UNEP website, the topic is the only one Earth. Yes, we have only one Earth. Even though Elon Musk and other people want to spend time to go to Mars, to Moon and other places, but in fact, until today, we only have one Earth. Then our Earth, as we know, right now are suffering for many problems. Air pollution, of course, and then the big one is the global warming, climate change caused by the greenhouse gases, land and ocean pollution, and so on. So this is our responsibility as human being, habitat the only one Earth, to protect, to preserve, to provide the better world for the future generation. This is our big responsibility. Of course, we must collaborate with all stakeholders, with all discipline, with all nations to get this big objective. That's why LPPM, Lembaga Penelitian dan Pengabdian Masyarakat, Center for Research and Community Services, is very happy to collaborate with ACS Publication, the world known big publisher in American Chemical Society. So this is the very good opportunity for us to collaborate to commemorate the World Environment Day. I believe in this opportunity, Professor Wonyong Choi and Dr. Windy Iriana will give us important insight about how to protect, to preserve, to provide the better world for the future generation. Thank you for your attention. Thank you for all participants who followed this important event in this morning. I believe this event will have important knowledge, will supply the important motivation for us to give a positive contribution for the preservation of our environment. Thank you once again, and I close with Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Yuli, for the speech. Before we continue, to capture today's event, we will have a group photo session. To all participants, please turn on your camera. Mr. Ali, please to lead this session.
Okay, take a photo. 1, 2, 3. Okay, watch again. 1, 2, 3. Next page. 1, 2, 3. Once again. 1, 2, 3. Okay.
Okay, thank you, Mr. Ali. Thank you, everyone, for your cooperation. We are going to have the presentation session of air pollution, the silent killer. The speaker of the session are Professor Wonyong Choi and Dr. Windy Iriana. After the presentation session, there will be question and answer panelist discussion, and all this session will be moderated by Dr. Anindrya Nastiti from Center of Environmental Studies. Dr. Anindrya graduated from Institut Teknologi Bandung in 2006 for her bachelor's, in 2009 for her master's degree, for her Ph.D. in 2017. She also received her Ph.D. in 2017 from Radboud University, the Netherlands. She currently working as an assistant professor of Environmental Management and Technology Research Group, Faculty of Civil and Environmental Engineering, Institut Teknologi Bandung. Her research mainly focuses on pursuing interdisciplinary research in intersection of environment and human behavior. She's also working as a freelance technical translator related to environmental and social studies. I would like to invite Ms. Anindrya to lead this session. Ms. Anindrya, time is yours.
Thank you, Ms. Karina. Good morning, ladies and gentlemen. Welcome to the World Environment Day 2020 virtual talk, Air Pollution, a Silent Killer. This event is a collaboration between LPPM, ITB, and ACS Publications. So as it has been introduced before, my name is Anindrya, and I am from the Faculty of Civil and Environmental Engineering and also the Center for Environmental Studies, Institut Teknologi Bandung. And I will be serving as your moderator for today. So you'll be hearing the presentations from two distinguished speakers on this very timely subject. The first one would be Professor Wonyong Choi. He's a chief editor of ACS ES&T Engineering, and Dr. Windy Iriana from Institut Teknologi Bandung. I would like to remind you again of the schedule that the presentation session will last until 10:10 Indonesian time or 10:11 Malaysian times, and followed by Q&A for 20 minutes. So moving along to our first speaker is Professor Wonyong Choi, and he received his BS honors from Seoul National University in Korea in 1988, and also the Master from Posttech Korea and PhD from Caltech USA in 1996. He then worked at NASA Jet Propulsion Laboratory from 96 to 98 as a postdoctoral scholar. And this year, he moved from Posttech to Korea Institute of Energy Technology, Caltech. And his research interests are mainly focused on semiconductor photocatalysis and photochemistry for solar energy conversion and environmental applications, advanced oxidation processes, and environmental chemistry. At the moment, he was appointed as Distinguished Professor Caltech in 2022 and Namgo Chair Professor in 2012, elected as Fellow of Korean Academy of Science and Technology and Fellow of Royal Society of Chemistry in 2014. And he received Young Scientist Award in 2015 and Korea Engineering Award in 2018. Since 2020, he is serving as an inaugural editor-in-chief of ACS ES&T Engineering. So Professor Choi will be speaking to us on diversifying environmental engineering research, ACS ES&T Engineering as a multidisciplinary platform. Please, Professor Choi, the time is yours. Thank you.
Right, thank you very much. Let me share my slide. Right, can you see the slide in full screen?
Yes, very well.
Well, thank you, Chairman, for a very, very nice introduction. And I'm very honored to be invited to this World Environment Day event. And I'm serving as chief editor of the ACS new journal, ACS ES&T Engineering. So in this talk, I'm going to briefly introduce the new journal and the scope. Then I will introduce some brief background of the air pollution, which is today's theme. And then I'll introduce some of my research related with the air pollution research. I'm not a guy specialized in the air pollution research, but some of my research is connected to the air pollution. So because the theme of this event is related with air pollution, I'll try to collect some of my recent research example related with photocatalysis. Right. So this new journal is just published last year, January, ACS ES&T Engineering. We are one of the members of the ACS family of journal. Our oldest traditional journal is Environmental Science and Technology. Everybody should know, the most prestigious journal in the environmental science and engineering field. And then later, Environmental ES&T Letter was established. And last year, ES&T Engineering and Water was also launched as a new journal. And although we are just in the second year of this journal. And so in the last year, we published about 153 articles. So as a new journal, our publication volume is not that large, but we are already indexed in Web of Science. And I expect the journal will grow rapidly as the time goes by, and especially for the impact factor, we expect to receive the first impact factor in 2024. So since then, the journal will rapidly grow. All right, so let me briefly introduce myself. I'm basically environmental chemist working on various kind of the environmental remediation technology. Especially my specialty area is photocatalysis. So I'm going to talk about some of my research example related with the photocatalytic air purification in the later part of this presentation. And I recently moved to the new university, Korea Institute of Energy Technology. We call it KENTEC. And I'm directing the Institute of the Environmental and Climate Technology in KENTEC. And I used to be an editor of the Journal of Hazardous Material for 9 years. And then I moved to the ES&T as an associate editor from 2017 to 2019. And from 2020, I accepted the editor-in-chief position of the new journal, ACS ES&T Engineering. So my goal is to make this journal as a top venue where the global community of environmental engineers choose to publish their best work. So we want to include not only the core environmental engineering area, but also emerging and interdisciplinary research area. So I want to this journal be an international platform of very diverse environmental engineering research and technology. And we started with a very prestigious team of environmental research scholars. We have 3 associate editors, and all of our very world-renowned environmental research. Professor Nancy Love from University of Michigan, and Professor Jae-Hong Kim and Yale University, and Professor Jun Ma from Harvard Institute of Technologies are associate editors of this journal, and they are all the world's best researchers in their specific research field. So I'm really honored to have a chance to work with them to launch a new journal, ACS ES&T Engineering. And our editorial advisory board are widely distributed globally. And there are many in North America, in China, and East Asia, and some Europe. And I'll try to expand more people from the Asian region as the journal is expanding. So if you are interested in serving as editorial board or early career board members, please try to submit one of your past work to this journal. So usually editorial advisory board and early career board members are selected from the frequent authors of the papers. So I really look forward to receiving your submission to this journal. So the vision for this journal, we want to be an international forum for high impact article on complex environmental engineering system. And then we want to include the diverse environmental engineering field, both traditional and emerging interdisciplinary research area. So, and we realize that the environmental research community is getting more and more diversified. So I want to make this journal to be a top venue, or where the diverse environmental engineers, environmental researchers from diverse background want to publish. Okay, so this is actually some of the specific topics we deal with. So generally, we deal with all kind of novel material technology, processes, and data analytic method and system that evaluate, protect, remediate water, air, and soil. So there are many technology related with this issue, like separation, resource recovery, nanotechnology, and biotechnology, catalysis, and analytical simulation method, or artificial intelligence. Machine learning is actually a new tool these days. And this kind of new analytical tools are being applied to the environmental engineering field. So as a result, the environmental engineering field is actually very diversified, and I want to provide the international forum for this diversifying environmental engineering research. So so we have probably only very few journal which has engineering title in the journal among the ACS publication, because ACS is actually a chemical society journal. Majority of journals do not deal with the engineering issue, but we do have engineering in the title. So engineering can be actually divided in various ways, but engineering is actually something that advanced technology and address human needs using basic scientific principle. So as a result, environmental engineering can be actually defined broadly. So when people think about environmental engineering, they probably, many people tend to think about the pilot plant scale demonstration of the environmental system or some large factory. But environmental engineering can be defined more broadly. We can cover various phases of the environmental dimension and target. So it's not only limited to the pilot plant system and scale-up system. It can be focused on the materials, or it can be focused on the specific processes, or it can be focused on the data analytics. So many diverse efforts of the engineering approach can be a subject of ACS ES&T engineering. And one of the key issues of the environmental engineering these days is diversification. So environmental research, traditional environmental research has been largely divided into the different compartments of environment, like water community, air community, and soil community. But nowadays, this kind of phase boundary between different environmental media is less important. So we are getting, the research is getting more shifting to multimedia research, and that's kind of the general trend. So I think the environmental researchers with various background is actually integrating to multidisciplinary research area. This is one of the a key characteristic of the modern environmental research engineering. And then the environmental issues are connecting with various other issues at creating various nexuses. For example, energy, water nexus, and environmental and then material nexus, and nexus with the sustainability, and nexus with the public health. That is actually diversifying, expanding environment. That reflects the diversifying and expanding environmental scope of the research scope of the environmental engineering. So, for example, environmental nanotechnology is one of the hot issues among the environmental energy research. So this kind of nanotechnology has been traditionally from the material society, but now more and more material scientists are applying their specialty to environmental issues. So environmental nanotechnology has emerged as a big research field. So this is one of the good examples of how this research has been expanded from the traditional environmental engineering area. And sustainability is obviously one of the most hot issues among the environmental research community. We are all worrying about CO2 accumulation and global warming and climate change. And this global change is actually affecting all fields of science and engineering, including environmental engineering as well. And public health issue is also closely related with the environmental engineering research, and toxicity of nanomaterial and microplastic, micropollutant, and then antibiotic resistant gene and viruses. I mean, this is all critical issues in environmental engineering research. And from the dimension, actually, the environmental engineering problem is getting more globalized. So from the local, traditional environment issue is largely focused on the local issue, but now we are more focused on getting more and more attentions are getting shifting to the global issue like climate change and sustainability. This is also a big change. And the dimension is also diversifying, and then not only just macroscopic system like a wastewater treatment plant or drinking water treatment plant. We are actually narrowing down the scope, microscopic dimension, like the study of microplastic and nanomaterial. But we are even further focusing, getting down to the molecular and atomic scale. The single atom, for example, single atom catalysis for environmental remediation and conversion is also a rising hot topic these days. So the dimension of the environmental engineering study is actually diversifying from the macroscopic to microscopic and even molecular and atomic scale. As a result, researchers from various backgrounds are actually coming into this environmental engineering research area. And this is actually the big change in the environmental research community. And I want this ACS ES&T engineering want to be the new forum, new platform for this diversifying environmental engineering research. Okay, so ACS, so articles published in ACS ES&T engineering is actually getting attention from the media, and we'll keep publishing hot issues in new topics in environmental engineering. And then what is the main essential point of the environmental engineering? So probably one of the biggest questions related with environmental engineering is how much do we affect the environment? This is probably one of the most key issues in environmental engineering. And obviously, the most important cause is chemical. So we use a lot of chemicals and every day and produce a lot of them and discharge many of the chemicals. And how this chemical affect the environment has been one of the most important themes of the environmental research. And realizing this threat of chemical pollution has not been very long, actually. We know the famous case of the Silent Spring publication. And this Rachel Carson published the Silent Spring in 1962, and then revealing the threat of the chemical pesticide. widespread use of chemical pesticide. And that is probably the initial starting point of the modern environmental engineering movement. And ever since then, people, the general public, start to realize that the importance of the widespread of the chemical pollution. The chemical pollution is caused not only in the manufacturing process, but during the use and disposal. Every process of chemical production, use, and disposal, they are released into the environment. So even after 60 years of the 60 years after scientific publication, the chemical pollution is more severe, getting more and more severe. Now the hottest issue is persistent microplastic all over the world, and all different kind of chemicals, persistent chemicals are found in almost every media of environmental compartment. So this is actually the biggest challenge we have in the modern days. So the environmental media is actually usually divided into different compartments. For example, the atmosphere and geosphere and biosphere and hydrosphere. And then we are looking, so all this environmental media is actually critically affected by the chemical pollution. So the majority of the effort of the environmental engineering research is focused on the how can you find the technology solution for protecting and remediating the environment, polluted environment. And this is actually one of the most important themes of environmental engineering. And when it comes to the atmosphere is actually unique compared to the other environmental compartment. For example, if you look at this, the thickness of the atmosphere, it's only 30 kilometers thick from the ground. It's about 99% of air mass is actually concentrated within the 30 kilometers. So compared to the Earth's radius, it's only 0.5% of Earth's radius. So very thin layer. So although our atmosphere, although we may tend to our atmosphere is an immense space, actually it's a very limited space. So as a result, atmosphere is the most vulnerable environmental medium. So when people emit something, chemicals in the atmosphere, they are easily damage and destroy this limited environmental medium. So this is actually unique of the air pollution. Air pollution is atmosphere is so susceptible to anthropogenic and industrial activity, which emit a lot of chemicals into the atmosphere. And then one of the probably most well-known chemical pollution example is CFC pollution and ozone depletion in the stratosphere. And as a result of the consuming and emitting a lot of CFC chemical, and that chemical accumulated into the and leaked into the stratosphere. And after photolysis, they generate chlorine radical and deplete the ozone in the stratosphere. This is a very well-known example of how chemicals degrade atmospheric environment. And ever since the scientists realized and found this problem, international community actually acted collaboratively and banning the production and use of CFC. And after the Montreal Protocol, the ozone layer is actually recovering very slowly, but the full recovery takes very long time. And this is a very typical example of the environmental degradation. Once the environmental is actually degraded, it takes a long time to recover. Sometimes it is irrecoverable. So this is actually most critical part. And there are other many serious environmental issues, air pollution issues. For example, chemical pollutant emitted in the atmosphere, they sometimes transform to the secondary pollutant, sometimes which is more toxic. So one of the most well-known example is a photochemical smoke. Many combustion process emit NOx and volatile organic compounds, and they react with the sunlight in the atmosphere, and they generate secondary pollutant like aldehyde, ozone, or fine particle. Particulate matter are also created and in situ generated within the atmosphere. And all this kind of chemical pollution actually dramatically affect human health and public health. So this is actually a big challenge that the society is actually facing. And another global issue is obviously CO2 rising, a rise of the CO2 concentration in the atmosphere. And now it is over 400 ppm. And compared to the pre-industrial level, about 290 ppm, there is a dramatic change of the CO2 concentration level. And CO2 concentration has been oscillating throughout the history of the Earth, but never above the 300 ppm in the history. Only recently, this rapid rise of CO2 concentration is observed, and this is mainly due to solely due to the anthropogenic activity. We are consuming and producing a lot of fossil fuel and CO2, and they are actually threatening our global environmental system. So nowadays, this global warming and climate change has been recognized as one of the most critical environmental issues in the community, in the international community. So air pollution issue is actually very unique and compared to the other environmental pollution issue. As I told you, the air atmosphere is the most vulnerable part. So once it's polluted with chemical, the impact of this chemical pollution in the atmosphere is devastating and more serious than other pollution. So I would say since the air pollution is the largest environmental health risk, so once it's polluted, everybody can be affected. So millions of deaths can be related with the air pollution issue annually. So this is probably one of the most serious environmental issue we are facing. And this environmental air pollution research, air pollution issue is actually involving multidisciplinary issues. It's very complex, and not only regulation and policy, monitoring and analysis, modeling and simulation, clean energy and process and innovation, pollution abatement technology, and public health. All different issues are actually involved in the air pollution issue. So this air pollution issue is actually one example how the engineering can contribute to solving this complex problem. So ACS, ES&T engineering actually welcome to publication of the air quality and air pollution related research area. So we recently actually showcased some air quality related article in the journal homepage. You can find some of the recent article which is related with air quality and air pollution published in ACS, ES&T. Okay, so from now on, so I just briefly introduced the background of the journal and air pollution, and I don't think I have much time, but I just try to deliver some recent example of my research related with air pollution, especially the photocatalysis. And the photocatalysis is actually a solar conversion method that utilizes sun's power to derive chemical redox reaction. So this kind of semiconductor photocatalysis has been widely utilized to degrade organic pollutant. Obviously, the chemical pollutant can be effectively degraded by the semiconductor photocatalysis. Semiconductor generates electron-hole pair upon excitation, and electron is a good reductant and hole is a good oxidant. So as a result of reaction with this electron hole with the organic chemical contaminant, a chemical contaminant can be transformed reductively or oxidatively into harmless product. This is actually the basis of the semiconductor photocatalysis research. So in specifically, so for example, if you're using TiO2 as a popular semiconductor particle, and upon excitation, a hole and electron react with oxygen and water, and they generate hydroxyl radical and superoxide, and they are highly oxidant, potent oxidant. They can degrade various kind of organic volatile organic compound VOC in the atmosphere. As a result, the VOC in the chemicals can be degraded as a result of this photochemical reaction. So this is one example of engineering method, photochemical engineering to degrade organic contaminant to the harmless product. So as long as sunlight is available or photon is available, it can work on the water medium. Also, it can also work in the air medium. So various kind of gaseous pollutant like volatile organic compound, NOx, SOx, sulfur compound, the indoor air pollutant can be actually degraded under irradiation. And this is actually basic principle of the photocatalytic air purification. So this semiconductor material is actually irradiated on light and under ambient condition and ambient pressure condition. As organic contaminant is passing through this filter, photocatalytic filter, and this activated species degrade the organic compound and degrade it to water and CO2. So this is a basic principle of the photocatalytic air purification. And this technology is particularly useful for indoor air purification because in indoor, the pollutant concentration is sub ppm level, usually sub ppb and ppt level. So low level concentration it's difficult to deal with such a low level concentration of pollutant. For example, in terms of the VOC removal, people usually think about the most common technology is activated carbon. Activated carbon absorption is probably most popular, but this is the absorption isotherm of the VOC. The activated carbon has a large surface area and has a large equilibrium absorption capacity. But that equilibrium absorption capacity is achieved only on the high concentration of the VOC. For example, in this case, formaldehyde absorption, equilibrium absorption is achieved only ppm, 25 ppm level. But that's too high concentration for indoor air. Indoor air, for example, volatile organic compound, aldehyde, is in the sub ppm level, ppb region. At such a low concentration level, absorption capacity of activated carbon is so low. So although the overall absorption capacity of activated carbon is very large, on the sub ppm concentration level, their removal capacity is so low. So absorption is not very efficient technology for removing a low concentration. And then activated carbon is also very sensitive to humidity because humidity is water molecule is actually competing with the absorption side as the humidity rapidly increases and the absorption capacity of the volatile organic compound rapidly decreases. So this is another demerit of activated carbon, but this kind of the photocatalysis degradation efficiency is not very sensitive to the humidity level. For example, optimal level of humidity is even helpful. For example, for all kind of the organic contaminant degradation, under dry air condition, degradation efficiency is this much, but under humidity condition, it's even increased because the water vapor is used as needed as a precursor of the radical species, such as hydroxyl radical. And then even if you increase the humidity level to 100%, much higher, they are comparable to the dry air condition. So the photocatalysis is less sensitive to humidity, ambient humidity level. This is another merit of this photocatalysis air purification. So the key issue in photocatalytic air purification, before with the degradation efficiency, higher degradation efficiency, and catalyst durability, and visible light active photocatalyst development is a key issue because we want to utilize solar light, and eventually we also want to utilize the indoor light as a light source without using any external light source. So this is actually a key issue and centered on photocatalytic air purification. And so as a result, diverse factors are being considered. So material science is obviously key issue. Reactor design, and then material coating, catalyst coating, and the durability enhancement and light absorption efficiency, and all they are contributing as a critical factor in enhancing photocatalytic air purification technology. And so let me show you one practical problem, one example, how this practical problem can be solved. So photocatalytic technology can be very efficient in degrading volatile organic compound. For example, so in that case, we actually coated on the TiO2 thin film on the glass surface and under UV radiation, and the toluene aromatic compound is rapidly degraded under light irradiation, and the concurrent CO2 is generated. So that means under irradiation, toluene is rapidly degraded to CO2 under ambient temperature and pressure conditions. The problem is the catalyst has a durability problem. So when you use the catalyst for second time, third time, fourth time, fifth time, you see the catalyst is rapidly deactivated and lose the activity. And eventually the catalyst turns from white to the yellowish color because this carbonaceous, recursion carbonate compound residue remain on the catalyst surface as a result of incomplete mineralization and actually deactivate the catalyst surface. So this is actually a very critical problem, especially for degrading aromatic organic compound. So how can you solve this problem? So we tried to solve this problem come up with the nanostructure TiO2. Instead of the titanium nanoparticle, we developed this kind of titanium nanotube structure. This is actually well-known material, and actually it's a columnar material, and then opening in the. So it's kind of you can think of it as kind of part of the plastic straw. Plastic straw has an opening inside, so TiO2 can be actually fabricated in this way. So we actually compare this performance as a photocatalyst between titanium nanoparticle film and titanium nanotube. So this is a top view, this is clear. This is a random agglomerate of the TiO2 nanoparticle, but this is a titanium nanotube. So the opening is very well aligned from the top view. So we actually compare this performance titanium nanoparticle film and titanium nanotube film for the repeated repeated use of the photocatalytic air purification. For the toluene degradation, TMP is rapidly deactivated, but TNT film is much less resistant, but much more resistant to deactivation, right? So this is actually clear. So TNT is much better in terms of durability. But the initial activity is similar, TMP and TMP. Initial activity on CO2 generations are similar, but with repeated use, and TMP is rapidly deactivated, but TNT is not. Why? Because this carbon residue are deposited on this red colored magnesium is actually incomplete degraded carbon residue. They are accumulated on the catalyst surface, and they actually can be rapidly reoxidized to CO2. But because of the oxygen mass transfer is limited through the measure process 4, and oxygen supply is limited. So there's a mineralization of this carbon residue is retarded. As a result, catalyst is gradually deactivated. But in the case of TNT, it has an open channel structure. So oxygen mass transfer is more facile. So this oxygen supply is much better. And this carbon residue is rapidly reoxidized under the fresh flow of oxygen molecule. As a result, deactivation of this catalyst is much less. So based on this concept, we actually tested the catalyst on the 100% oxygen. So in the previous cases, this is on the air. So only 20% is oxygen molecule. So the oxygen mass diffusion is limited by 20% oxygen. But on the 100% oxygen, there is much more facile mass transfer, right? This is obvious. So as a result, in this case, TMP, even TMP shows a much more resistant deactivation because oxygen supply is much higher and was TNT, but still it shows a gradual slight sign of deactivation. But in the case of TNT, you see there is no sign of deactivation. So this is actually a very clear sign that this more by controlling the morphology, you can make the photocatalyst more resistant to deactivation. So the next idea we come up with, okay, this oxygen mass transfer is so critical in maintaining the activity, durability of the catalyst. What about removing the bottom of TNT? and make a doubly open nanotube. This is in the typical TNT, titanium nanotube, the bottom end is closed, so the oxygen mass transfer is actually blocked and it's actually limited. But by removing the bottom of this TNT, making the both end open, we expect this oxygen mass transfer will be more facilitated. So that was our hypothesis. So we tried to actually demonstrate this hypothesis. And this is one instance. So we fabricated TNT and DNT, doubly open. So TNT case, the bottom end of the tube is closed, but DNT, doubly open TNT, is actually the both top and bottom and are both open. So we actually compared the TNT and DNT for tolerant degradation. So compared to the TNT, TNT shows actually a little bit higher degradation rate and faster rate of CO2 generation. In addition to that, this DNT is much more resistant to deactivation. For example, in the case of the black sample TNT, it undergoes the gradual deactivation, black symbol. But if you utilize the DNT red symbol, it does not show any sign of deactivation. So this is actually clear, very clear evidence that by allowing oxygen mass transfer through the sample, photocatalysis sample, you can actually make the catalyst more resistant. So based on this, we further developed this TNT by modifying this crystalline structure. So we find a way to develop more 001 crystalline flame on the TNT surface. And 001 surface of TNT is known to produce more hydroxyl radical. So by engineering this TNT tube and by exposing more 001 surface on the TNT surface, we can actually make a better photocatalysis for air purification. So for example, compared to normal TNT, the 001 TNT has this 001 crystalline plane is more developed. So, and when you compare the tolerant degradation for TNT and 001 TNT degradation, obviously degradation rate is faster because more hydroxyl radical is generated and more resistant toward deactivation. Again, normal TNT, black symbol, they undergo gradual deactivation. But with the 001 TNT, red symbol, it does not show any sign of deactivation. So this engineered TNT is actually better resistance toward the catalyst deactivation, and is actually a better photocatalyst for air purification. So we actually scaled up this 001 TNT filter from in the laboratory. We just fabricated 1 centimeter by 1 centimeter, very small sample size. We scaled up to 30 centimeter by 30 centimeter, and then we installed this TNT in the commercial air cleaner, and then installed UV LED as a light source, and then we tested this photocatalytic air cleaner in the 8 cubic meter chamber, and then we tested VOC removal capacity. And we tested 5 target gases on the 30-minute operation in test chamber of 8 cubic meter chamber. After 30-minute operation, if you can remove more than 70%, it's actually passed commercial air purifier test. So the just normal TNT is not good enough to pass the 70% target line, but 001 TNT, they actually are successful in achieving 70% removal. So this photocatalytic air cleaner contains photocatalyst only. No activated carbon is included. Only photocatalyst. We were able to achieve 70% removal within 30-minute operation. So this is actually a good example how nanomaterial can be applied to purify air. Okay. And then this about the deactivation, this in terms of the component, elemental component, this the presence of heteroatom is very critical. For example, C3 carbon, when you have the aldehyde and alcohol compound, ABCD means the first, second, third, fourth cycle. With repeating the cycle, activity is maintained. Degradation activity is maintained. But When you have a nitrogen-containing compound, sulfur-containing compound, you see the activity is rapidly deactivated with repeated cycle. This is because this nitrogen and sulfur has a non-volatile product like nitrate and sulfate. Actually, they accumulate on the catalyst surface. This is actually surface analysis of the photocatalyst after use. You see after use, sulfur and nitrogen element is found. This is because this nitrogen sulfur species are accumulating on the surface as a non-volatile product. As a result, it actually covers the deactivated photocatalyst surface. So the catalyst photocatalyst deactivation depends on many parameters. It depends on catalyst morphology, and also depends on the composition of target gases and reactor and reaction condition. So a lot of the parameters should be considered to make the photocatalyst more resistant for the catalyst deactivation. I think my time is already up. So how much time do I have?
Yes. Well, actually, because we are a little bit late in the beginning, so you have like 4 minutes. Yeah.
Oh, okay, 4 minutes. Okay, great. And this is another example of the photocatalyst air purification photocatalyst development. And the key issue is the visible light utilization. For example, TiO2 I introduced in the previous section is not active on the visible light because it cannot absorb visible light. So how can you utilize visible light? Because if you can utilize visible light, you can utilize more sunlight, and we can utilize even indoor light as well. Tungsten oxide has a lower band gap and can absorb visible light, but the bare tungsten oxide is not very good photocatalyst. Platinum nanoparticle loaded tungsten oxide is a good photocatalyst, but platinum is very expensive, so it's always a cost issue. So we tried to replace this platinum with the cheaper material, and we come up with the nano diamond. This is a carbon nanocrystal coupled with the graphitic carbon layer. Although the name is diamond, it's much cheaper than platinum because it's just carbon, right? And then we load this nano diamond or tungsten oxide surface, and we found that this as an air purifying catalyst for VOC degradation. We noticed that this nano diamond loaded tungsten oxide is almost comparable to platinum loaded tungsten oxide in terms of the acetaldehyde degradation and concurrent CO2 generation. Compared to the bare tungsten oxide, their performance is very limited, but by loading tungsten oxide, nano diamond on tungsten oxide, we can make this material very effective for degrading volatile organic compound in the atmosphere. So with repeating the cycle, we see the catalyst show the durability with the rapid removal of the acetaldehyde and concurrent production of the CO2 was observed. So this is one example of how this nanomaterial can be also modified and engineered to make it more visible light active and more active for controlling air quality. And we recently invented a very interesting method of making visible light tungsten oxide photocatalyst. And by coating iodic acid, which is a hygroscopic, we observed that in situ water layer is formed by absorbing ambient water vapor and condensing it on the surface and make the surface hydrophobic, highly hydrophilic. And as a result, hydrophilic volatile organic compound can be highly dissolved and concentrated within this water layer, surface water layer, and volatile organic compound can be rapidly degraded. For example, compared to for the acetaldehyde degradation, compared to just tungsten oxide, this iodic acid coated tungsten oxide shows a much faster degradation of acetaldehyde and CO2 generation, and it's even more effective than platinum loaded tungsten oxide for removing acetaldehyde. So iodic acid is much cheaper than platinum, but it still shows it's nevertheless is very effective in removing acetaldehyde from the air. But interestingly, so it showed it maintained persistent activity for repeated uses. But interesting thing, this effect is only specific for hydrophilic VOC. So iodic acid loaded tungsten oxide is only effective for hydrophilic VOC like acetaldehyde, acetone, methanol, isopropyl glycol, they are all hydrophilic compounds. Only hydrophilic compound can be effectively degraded by this system because they can dissolve in water layer, but hydrophobic VOC like dichloromethane, alkane, or toluene, they cannot dissolve in the water layer, so they cannot be removed by this quality acid tungsten oxide system. So this is one example of selective photocatalysis. By using this kind of technique, we can selectively removing hydrophilic VOC only using this unique photocatalytic system.
Professor Choi, yes, your time is up.
Okay, so I'm just summarizing my talk. And environmental engineering research area are rapidly expanding and merging with beyond and expanding beyond the traditional environmental engineering area. And I want to make this ACS ES&T engineering as a platform for this diversifying environmental engineering research. And atmosphere is the most vulnerable environmental media, and the pollution, atmospheric pollution, is actually a very critical issue. And I introduced one example in the photocatalysis as an emerging promising technology for controlling air quality in the ambient atmosphere condition. And I thank my research group and funding agencies. And I greatly thank for your kind attention and invitation. Thank you.
Thank you so much, Professor Choi. So Professor Choi has introduced the Environmental Science and Technology Journal series and the various new topics for environmental engineering. And he also provides an insight on his research on photocatalytic degradation of, especially on volatile organic compounds. So for the audience, if you have any questions, please do drop them on the chat box and we will visit them later on the Q&A session. Thank you once again to Professor Choi. And now we move on to our next speaker, Dr. Windy Iriana. Can you please, the host please, the bio for Dr. Windy? Thank you. So Dr. Windy Iriana is actually my colleague from Center for Environmental Studies. She obtained her PhD from the University of Tokyo in Japan in 2019, and then she worked as a visiting researcher in the Atmospheric Environment Systems Laboratory in Tokyo, the University of Tokyo from 2019 to 2020. So since August 2021, she moved to Institute Teknologi Bandung as a researcher and lecturer in the Faculty of Civil and Environmental Engineering, also in the Center of Environmental Studies. And her research interests mainly focus on air quality monitoring, greenhouse gas monitoring from disturbed tropical peatlands, and personal exposure of air pollutants. And currently, she is working on collaboration project with the Indonesian National Research and Innovation Agency, or BRIN, the Indonesian Agency for Meteorology, Climatology, and Geophysics, BMKG, and the University of Tokyo and Kyoto University. So she will talk about the correlation of publication frequency of newspaper articles with environment and public health issues of fire-prone peatland regions. So please, Dr. Windy Iriana, the time is yours.
Okay, thank you, Bu Asti. Can you hear my voice clearly now?
Yes, perfect.
Okay, we'll share my screen. Okay, good morning, everyone. My name is Windy Iriana. I'm a researcher in Center for Environmental Studies, Bandung Institute of Technology, and also staff in Air and Waste Management Research Group in Faculty of Civil and Environmental Engineering, ITB. So today I will share my research with you. The topic is about the use of the publication frequency of newspaper to support data of public health issue. And this is the location is in fire-prone Peatland area and Riau in Sumatra, Indonesia. Okay, so as you can see here in the background, so this is the picture I took on 2012 during my master study, and this is showing the peatland fires in Bengkalis region. So maybe later I will recall these pictures. Okay, so for you who live in Indonesia or probably in Southeast Asia, especially in Malaysia and Singapore, you might familiar with this kind of headlines during the fire events. So yes, the peatland fires in Indonesia give negative health impact for the environment and also for the health. It's disturb your daily activities. Like here, you can see even from 2 years ago, before the pandemic, during the hay season, people were encouraged to put on their mask, and then also it disturbs daily life by, for example, the school should be stopped, and then disturbance in airport operations, and the most important things, it's have threaten people's life. Okay, so actually, how often peatland fires in Indonesia occur? So here's in the figure, you can see this is the MODIS hotspot count from 2001 to 2017, and this is MODIS hotspots is indicator for the viral occurrence. So as you can see here, that peatland fire in Indonesia occurs every year, unfortunately, especially during the dry season, when the temperature is high and the precipitation number is low. And you can see here the red bar here. This is indicating the years, ENSO year, or you might familiar with the term El Nino during the El Nino season. And yes, during that season, the fire's hotspot number is so much higher than the non El Nino season. Okay, so actually, what is being emitted to the atmosphere during the peatland fires? Okay, so here we can see here, this is it's written what fires and forest fire, but for Indonesia, it's usually a peatland fire. So yeah, peatland fire is one of the air pollution source. So if we can divide it into two, there's a natural source for air pollution, and also there's an anthropogenic source for air pollution. Yeah, for a natural source, it can be like volcanic eruption, and for the anthropogenic one, yeah, it's from our daily transportations, and then industry, and then agricultures, and then activities in the cities. Okay, so peatland fires emitted various kind of air pollutant. There's gases and also particulate matters. And also not only air pollutant, but it also emitted greenhouse gases. So for example, here, peatland fire emitted CO and then SO2, and then also some climate gases, NH3, and then CO2, and also particulate matters. Okay, so but one of the important things that we should be highlighted here is that the impact of fires on peatland fires on air quality is not limited to the haze source region alone, but because it can be transported 100 kilometers away, so it's a given like more global impact, not only local one. Okay, so as I mentioned before, that the peatland fire emitted not only air pollutants, but also greenhouse gases. So this is the data from the Global Fire Emission Database. This is from 1997 to 2015. Okay, so this is the bar here showing the fire emission from Indonesia that's equal to CO2 emissions. And then in the right side here, we can see this is the fossil fuel CO2 from various countries. And then as you can see here, for example, in 2015, so the the emissions of peatland fires, CO2 from peatland fires. It's even exceeding the emission for fossil fuel from Germany and Japan. Yeah, so it's a peatland fire is serious environmental issues. Okay, so then next. Okay, so what is the relations between the peatland fires emissions and the health impact? Okay, as we previously discussed before, so the peatland fires emitted various kind of air pollutants. So maybe here in this research, we highlight to the emissions of particulate. So in this haze, it's contain a pollutant called PM 2.5. So PM 2.5 is a particulate matters that have a very small size. As we can see here, compared to our hair, it's here the pink color is show the size of the PM 2.5. And PM 2.5 can penetrate into our nose, throat, and can penetrate more into our lungs and also our alveoli. So the impact of air pollution, it can be for the health, it can be seen in the short term and also for long-term period. For short-term period, it's obviously it can give some, it can cause irritations of eyes, nose, throat, and breathing problems, or we can call it here acute respiratory illness, or in Indonesia we call it infeksi saluran pernapasan atas or ISPA. But in a longer time, it can be more serious. It can lead to cardiovascular disease, and then problems that, for example, chronic obstructive pulmonary disease, and then also have can be impact to the reproductive systems. Okay, but in this research, our group focusing on the short-term impact in acute respiratory illness. Okay, so actually, yes, speaking about environmental issues, it's very important to quantify the level of pollutant, and then defines like the impact, so we can do something related to the management of the environmental and also public health. But for example, in this case, air quality data and then epidemiology information is very important to make some plan action plan for the public health related to the forest fire. But unfortunately, the data that we have is not always available. And for the measurement itself, for example, air quality measurement, it's not easily conducted, especially during the fire season. It's pretty hard to make a good monitoring. So that's why our group here is aimed to reveal utility of newspaper articles for estimating the public health concerns posed by air pollutions. Okay, so in this study, we're using a newspaper database. So here we use the database from Riau Pos. Riau Pos is a local newspaper, and we purchased the newspaper from 2009 to 2018 from the company. But yeah, unfortunately, still, even we try to use a digital database, there's still some missing time frames here. The missing time frames, and this missing time frames is excluded from the study. And yeah, this newspaper typically publishes about 40 pages daily, and it covers news from Riau province and its nearby regencies. So not only from the Riau province, but also from the nearby regions. Okay, and then we try to formulate the search terms that can be used for this study. And this is several search terms that we use to correlate with the environmental indicators. Okay, so next, here we can see here, this is the satellite image of Rio province, and this is on June 14, 2012. So if you still remember the pictures from my first slides, so this is actually one day after I took that pictures, and the pictures was taken in here. This is, you can see dense haze from here. So here, the red dots here, it's showing the hotspot location. So this is the fires, locations of the fire. And you can see this is the white colors. This is the haze from the this is the haze from the Peatland fire. Yeah, and then yeah, you can also see here that this is the haze is transported to Malaysia here. Okay, and so to correlate the newspaper's page number, so here we use two parameters. The first one called fire radiative power, or FRP, and the second one is the airport visibility data. So FRP is a product from the MODIS sensor for the Terra and Aqua satellites. I will discuss more about this in the next slides. And then also visibility, airport visibility data. As you know, that visibility is one of the informations that very important in the aviation industry. So usually when the visibility is low, the flight should be canceled, yeah, because it's dangerous for the passengers. And then here we can see here for the visibility, of course, that the haze emitted from the peatlands directly reduce the visibility. Okay.
Dr.
Next,
Windy,
yes.
Yes, your time is like 5 minutes.
Okay, thank you.
Left. Thank you.
Okay. So this is the fire radiation power, the FRP that I mentioned before. So what is the FRP? So FRP is actually a measure of fire release rate of thermal radiation, and it's strongly related to the rate of fuel consumption and trace gas and aerosol emissions. Or in a short way, it can be used as an indicator to the concentrations of the air pollution that emitted to the atmosphere. And from other research, it mentions that it's found strong correlations between the FRP and PM 2.5. So yeah, FRP can be used as indicator of the air pollution. And also visibility that we previously discussed, it's also has a correlations with the aerosol density. Yeah. Okay, so here we can see this is the map of FRP. So in this study, the centers of the study is in Pekanbaru. Pekanbaru is the capital city of Rio province, and we use the FRP data for 100 kilometer radii here. So this is what we use for the correlations. Okay. Next, this is the correlations between the FRP and the number article page. So as I mentioned before, there are some search terms that we use. So this is the article page number from yearly annual article page number for acute illness, smoke damage, air pollution, and peatland fire. And this one for the FRP. Here we can see for ABC, the increase of the high number of FRP is along with the article page number. And for here, we make the correlations between that article page number and the FRP. For acute illness, the correlation is 0.82. For smoke damage, here is 0.64. And for the air pollution is 0.79. But for peatland fires, so in the case of the search term peatland fires, it don't find, there's no strong correlations between peatland fires search terms and the FRP. So apparently it's because the peatland fires number is very high. So probably this term is discussed not only that related with the environmental issue, but other issues. So the numbers of articles are very high. So for peatland fire, we try to do more deep analysis, but probably I cannot discuss it here because of the time limitations. But after we break down the page number, we find a correlation of 0.43. Okay, and this one, the correlations between FRP and the numbers of article page during the fire-prone period. So as we can see here, this is the monthly hotspot count in Riau for 2011 and 2012. And we can see usually the peatland fires in Sumatra occurs 2 times. The first one is around January to February, and the second one is from June to September. And we can see here, this is our result, the article page number for the search term acute respiratory illness. And yeah, we can see this is the peak also from around February, and here is from June, the search term is start to increase, and this is the coefficient correlation for this, and with the time lag 0, 1, and 2 months. So yeah, it's indicated that the illness came around 1 month after the fires occurs. Okay. And then next, this is the correlations between FRP and numbers of article page containing acute respiratory illness with the geotag of the city name. Okay, so we try to see per locations, with the special information. For example, for this graph, this is the article page number for acute respiratory illness plus Pekanbaru, and also FRP. And we can see here the correlation coefficient is 0.63 and 0.78 with time lag 0 and 1 year. So the slightly higher R value, the 1 year lag suggested that the newsworthiness of risk perception is partly developed from the public experience in the previous year. Okay, and this is the regional dependence of page number of article mentioning both acute respiratory illness and the city name. So here, this one, the name of city in Riau province, and this is the neighbor province, which is West Sumatra. And here we try to make the ratio of the page number and also the population. And this is, we can see if we compare it with the data from health department. So in the health department data, the statistic of pneumonia case for children under 5 in 2018 and 19 reported the percentage that the highest one is Siak, following by Dumai here, and then Pekanbaru, and then Pelalawan, and the last one is Bengkalis here. So we can see here that in the number of the order of magnitude of ratio, and also this data from the health department is comparable, except for Pekanbaru. Yeah, maybe because Pekanbaru has the highest page number because it's the biggest city in the province. Okay, so this is my last discussion. This is the spatio-temporal variations of the reverse value of visibility. So we discussed before that visibility also can describe the air pollutions from the peatland fire here. So this is, we can see here for Pekanbaru. In Pekanbaru, the visibility peaks in 2014 and also 2015. This is synchronized with the peaks in the annual numbers of page for acute respiration illness that I previously present in slide 13. And then next for the eastern side here, eastern side of the central region of Sumatra, Pekanbaru and Rengat, is several heavily from haze compared to the west side regions of Padang. And these observations also support the result of the previous ratio that I show in the previous slides. Okay, So here's the end of my presentations. So the conclusions for these presentations, first ones, newspaper epidemiology information is not generated with the primary purpose of doing epidemiology, but we can use it as a useful source in the analysis of public health and environmental context. And then this study has revealed the utility of articles from local newspaper, in this case, Riau Pos, for filling in estimates of acute illness and acute respiratory illness related to air pollution. And newspaper analysis can be potential tool for public health sector for estimating health impact from deteriorated air quality due to peatland fire. And then newspaper play important role in framing peoples about their initiatives taken to manage such social issue. And yeah, it's the interdisciplinary scientific framework to evaluate public health implication is in publicity available through decision support tools of mass media. And yeah, we hope that this research can be continue and can give insight for public health and environmental issues in Indonesia. Okay, so this is the end of my presentation. So thank you very much.
Thank you, Dr. Windy Iriana. So that was really an interesting presentation. So now we come to the Q&A session. And I think we only have time for at least 3 questions. So the first one, I would take one from the chat box here for Professor Choi. The first one, are current air filters effective in reducing virus particles in indoor environment? Thank you. Please, Professor Choi.
Okay, so the photocatalysis filter is mainly for destructing chemical. So particle or virus removal is not the main function of the photocatalysis. But if this photocatalysis is combined with the other filtration membrane, I think this is, it has a synergistic effect. So filtration can remove virus and particle, and then photocatalysis components can deactivate the virus, for example. That's how it works. But photocatalysis itself is not effective in filtering dust or viruses, but it is effective in inactivating the virus.
Okay, thank you so much for your answer. Now, moving along to our second presenter, we have a question about the early warning system of the peat or forest fire in Sumatra and Kalimantan. For example, a big network and low-cost environmental sensors, suppose that we have those. Can we precisely handle the fire immediately, or what are needed to do so? Thank you.
Okay, thank you for the question. Yeah, for early warning systems, actually, I think it's available right now. Like for example, like what I present before from the satellite. Usually it can give early warning, and then the fire immediately. Okay, for the peatland fires, the problem is the fire is not in the surface. That usually what make it difficult. So in the case of peatland fires, the fires is underground fire. So usually we cannot finish the fire easily, because we know it's already spreading in several areas. So probably that's the main problems. To my knowledge, there's a lot of research also currently developed how to extinguish the fires, and the technology and others. Yeah, probably that's my answer.
Okay. Thank you so much. Again, I think we still have time, because there are quite a number of questions here, but I'm going to take one. For Professor Choi regarding the filtration, is the charger efficiency good enough to remove particulate in the air? Because in Indonesia, many products like ion generator with low flow rate or air purifier with limited information or performance are available during the pandemic. What's your take on this?
I actually do not understand the meaning of charger efficiency. What do you mean by charger efficiency?
Okay, we have the question from Pak Indra Chandra. Maybe you can open your mic a little bit.
Thank you very much, Professor. The charger efficiency is like an ion generator. We usually release the electron to the air, and then the electron can capture the particulate, something like that. Is it clear enough, Professor?
Well, actually, as I mentioned in the previous question, the photocatalysis itself is nothing related with the particle removal, actually. It's very different from mechanism. So the main function of photocatalytic filter is generate reactive oxygen species, radical species, and that radical species degrade organic contaminants. So particle removal is a different part. It's hard to compare. So photocatalytic filter itself has no function for particle removal. Would that be answered?
I see. Okay. Thank you very much, Professor.
Okay.
Okay, thank you, Pak Indra and Professor Choi. Another question for Dr. Windy. Would you please describe the comparison of effects of peatland fire and other source of air pollution? Thank you.
Okay. So for the effect, I think is actually probably almost the same, but the difference is the magnitude. So during the peatland fires, that's a huge amount of emissions emitted to the atmosphere. For example, if we compare to the transportations, yeah, probably the exposure is daily, but during the peatland fire season, it's seasonally, but once it happens, it's like give you very massive impact. Okay.
Okay, thank you. And let's go back to Professor Choi. This is about ACS, ES&T engineering journals. Does it receive the article about solid electrolytes of lithium-ion batteries?
Hold on a second.
Solid electrolytes of lithium-ion batteries. This question from Bibiana.
Yeah, if it's only focused on the lithium-ion battery, it's out of scope. But if we deal with some kind of lithium recovery from the spent lithium-ion battery, then it should be a scope within the scope of the journal.
Okay, thank you so much. I hope that answered your question. And then another question for Dr. Windy. We still have time, like a couple of minutes again. How or what are the steps to mitigate the emission of air pollution? I mean, what are the constraints to reduce the emission?
Okay, so actually to mitigate, to reduce the emission, we hope that the forest fire even itself is reduced. So it's kind of complicated because it's if we can reduce the numbers of forest fire, then it will reduce the numbers of the emissions, I guess.
Okay.
I hope that's answering the questions. Okay.
And there's a follow-up question about health as well. So is there a real difference between cases of pneumonia and cases of forest fires in certain areas?
Yeah, so actually I cannot say. So from the study that we mentioned before, there's correlations, but I think it's need a further study to say that is it directly related to the pneumonia and the fire itself. But yeah, according to the study that we've done, there's a correlations of numbers of pneumonia in the fire-prone area.
Okay, thank you. I think our time is up because we only have like 10:30 for the Q&A session. So I would like to thank you once again to Professor Choi and also Dr. Windy Iriana for your excellent presentations and insights related with air pollution and also the impact on health and also the technology to reduce the pollution, especially in the indoor environment. We are honored to have you. Thank you so much once again to Professor Choi and Dr. Windy Iriana. And for the audience, I hope that you are satisfied with the answers. And I think you can find the contact of Professor Choi and Dr. Windy Iriana in the respective website of their workplace. So please do contact them. And also I would like to return the floor to the MC, Miss Karina Dwianti. Thank you so much.
Thank you to Miss Anindrya and also the speakers for the session. And the next agenda is introduction from ITB Student Chapter. I would like to invite the President of ITB Student Chapter, Ms. Rasha Iza. Time is yours.
Okay. Good morning, Professor Choi, Dr. Yuli, Dr. Denny, Dr. Windy, Dr. Anindrya, Dr. Rino, and LPPM ITB, Ms. Mandy, and to all participants. My name is Rasha. I'm the president of ACS Institute Technology Bandung Student Chapter. I'm honored to have the opportunity to represent ACS ITBSC in the World Environment Day 2022. We are glad to announce that we have successfully held our student chapter activities for this year, as shown in the video after this, and we have collaborated with ACS UTM-SC from Malaysia, NUS ACS SC from Singapore, and Octan ITB. On top of that, we came up with a new event called InPace International Paper Competition, which has been held last February 2022. And for further information regarding our student chapter, please kindly check our Instagram account at ACS ITBSC. Thank you.
American Institute Teknologi Bandung Student Chapter, recognized on October 12, 2020 by the Council of American Chemical Society, is the first international student-led organization in chemistry and related sectors in Indonesia. In our first year, we have more than 30 active members majoring in chemistry, pharmacy, biological engineering, and many more. Kickstarting an organization may be easy, but sustaining it is another story. With the help of American Chemical Society and Institut Teknologi Bandung, we were able to build a constructive environment for every member. This past year, we had various intimate talks covering versatile topics with leaders around the world to strengthen our soft skills in an event called Internal Forum. Not to mention our classes tailored to every member to get their hands on and discover more about project management, marketing, copywriting, treasury, public relations, human resources, and many more. Not only did we develop ourselves, we also strove to create a greater impact for society. We hosted 4 science-related free webinars and workshops with more than 3,000 attendees worldwide, made possible with the help of our collaborators. The fact that ACS ITBSC is an international organization is both challenging and fascinating for us. American Chemical Society helped us broaden our network by connecting us with another international student chapter. Recently, we had a cultural exchange event with ACS University Technology Malaysia International Student Chapter, where we gained a lot of new perspectives of the 2 different countries, despite being held online. We hope that ACS ITBSC will continue the journey alongside other student chapters, chemistry student organizations, and everyone who shares the same spirit with us.
Okay, thank you for Ms. Rasha Iza for the introduction. And the next agenda is World Environment Day quiz from ACS publication. The session will be conducted by Ms. Karen Yeo. To Ms. Karen Yeo, time is yours.
Hi, everyone. I hope you can hear me. So,
Yeah.
So I'm in this session. So Mandy, could you kindly put it through the next slide? So having heard all the presenters speaking today, and then I think we will want to really end this with a interesting quiz. We have some rules to the games, and it's a really trivial questions, 5 trivial questions, and here are the game rules. The fastest person to get the correct answers will be chosen for each question. And kindly just type your answers in the chat box to qualify. Definitely, we reserve the rights on deciding the correct answers and winners. And winners should also stay on at the end of the game to provide your details for the quiz. We have really, and we have 5 Grab vouchers to be won. So, so moving on, I'm passing this to Mandy to go ahead with those questions.
Yes, good morning, everyone. So I would like to work together with Karen for this World Environmental Quiz. I think if you remember last year, we have the similar quiz given. All this will be more toward the awareness. So we are not so emphasized that, oh, this will be the data, the fact and the figures that we put it in. So it will be 5 questions. Please put into your chat box. Then we'll be announced who will be the winner for the sessions. Okay, the first questions. Which country is the host for the World Environmental Day 2022? So my colleague will help me to see who will be the winner on this. Karen, do you manage to find anyone? To put in the answers. Which country is the host for the World Environmental Day 2022? So this year is the...
I have not gotten any answers in the chat box. I think people are Googling.
Yeah, you're allowed. World Environmental Day is celebrated annually on the 5th June. So we make it earlier due to this will be the weekend. So we do it this today. And this is the United Nations Principal Vehicle for encourage a lot more awareness and action for the protection of the environment. So World Environmental Day is every year there will be a host country. So our question is, which country is the host for 2022? It was the same host 50 years ago. So they were using the same theme, only one Earth. Okay, will be 50 years ago, the same host hosting it for this year. So at least this is something that we make it easy for you to find the answer. Which country? That if you look into our profile photos, that will be an indication that will be a very beautiful country, which is very sensitive to the environmental, the protections. Okay.
We got a winner.
Yes. So the answer is, let me announce it. The country who holds it is Sweden. Yeah. Please leave your contact for us so that we'll be able to reach out. So this year, after 50 years later, Sweden is the country who holds the event, okay, for the World Environmental Day this year. With the same theme, only one Earth. Okay. The second question. Which greenhouse gas account for 80% of the greenhouse gas emissions? If you pay attention to Dr. Choi's, Professor Choi's sessions, which gas, okay, the greenhouse gas account for 80% of the greenhouse gas emissions? So you look into the chart. I think Prof. Choi have been highlighted so much. Okay, so according to the United States Environment Protection Agency, this gas is particularly the great contributor for the greenhouse gas emitted through our human activity. Hope everyone will be very easy. This is a common understanding for us. Okay, we need to be more sustainable and a green environment. So we need to reduce this gas in our daily activity. Is there an answer there?
Yes, we do.
Yes, congratulate for the winner. Okay, it's a carbon dioxide. So this is the primary greenhouse gas emitted through the human activity, like transportations, like the manufacturing, the industry activity. Okay, so we like to pay attention to how to reduce this. The next question is related questions. Which economic sectors emit the largest percentage of the greenhouse gas emissions? Okay. Based on the report from the United States Environmental Protection Agency, the global emissions activity, by the economic activity, that will be the ranking of it. The first one, that will be the answer, will be at 27% of the 2020 global greenhouse gas emissions. So that will be the commons that we look into. And we also see other activity will be other contribution for this. If you're sensitive enough to see the previous questions, we show the indicator.
Yep, become a winner too.
Yes, congratulations. This is a transportations. Yeah, transportations is really contribute 27% of the 2020 global greenhouse gas emissions. The burning of the fossil fuel of our cars, trucks, the ships and trains and planes. Yeah, so I think during the COVID-19 lockdowns, people stop traveling. We see our environment and our air is become clearer and the sky is bluer. So that we see the effect of what type of contribution from the human activity. Okay, 2 more to go. The question is, the World Health Organizations, the WHO, estimate how many million premature deaths per year due to outdoor air pollutions. So it's just a guess of how big the number. Yeah, that will be the premature died every year from our outdoor activity. And we'll be able to see, okay, a lot more activity cause the death of our human. But at the same time, we also will be the great contributor of this. So we just want to know how many million premature deaths per year. We encourage you to Google. This is more toward the awareness quiz that we encourage our user to be more aware to our environment, to what will be the impact to our humans, and what will be the thing that we can prevent and restrict. Any answer?
Yep,
from
we
the
got
floor?
winner too.
Yes, congratulations. The answer is 4.2 million die prematurely every year from the outdoor activity, from the air pollutions. And we'll see other death from other activity. But this is quite a significant numbers. 4.2 million is something that we take into our considerations. Okay, this will be the last questions. How many percent of the world's populations live in places where air pollution level exceed the WHO guideline limit? How many percent the world population live in places where air pollution level exceed the WHO guideline limit? This is another awareness questions. By the fact and figure, you're able to have a gauge how serious, okay, we are living into an area, the air pollution level exceed the WHO guideline limit.
More. We need
Closer to it. Karen can give her indications. The number is closer to the answer.
Yeah, giving a hint. It's more.
You look into the rest of it, giving the answer from the chat box. If you have 100%, closer of the 100%. We are very generous. Because the
We
purpose of
always
first,
have to put the most difficult answers at the last question. More.
we encourage more participants. This is a bonus questions. Yeah. What is the closer number to 100%?
More to 93% higher. I'm giving away prizes like that.
You reach the answers?
Oh, close up.
Everyone can participate into it. So this is an awareness quiz. How many percent of the world population live in the places where air pollution level exceed WHO guidelines limit? You find the answer?
No, not yet. Ika, you are more. You just need one more. So obvious.
Okay. We encourage people there to put more in the numbers.
Yay. We
Finally.
Yep.
Actually, the answer is very straightforward. Yeah, it's almost there. Only 1% of the world population is not. So 99% of the world populations live in places where air pollution level exceed the WHO guidelines limits. Why we have this kind of questions to you? Because it's not to guess the number, the figures, but it's more toward to create awareness. World Environmental Day is a day for us to really want to treasure. We only have one Earth. So where we're living in it, we cannot spare for this is the world issue, the global issue. It's not the regional authority. But I know all these things is not easy for the past so many years, so many act, laws, regulations have been put in, but it doesn't work that well because it's all come from individual. Yeah, so I would like to thank Karen's. Okay, please leave your contact in the chat box. We will be able to arrange to send our prices to you. Yeah, so without further delay, I also take over for the session for the closing remark. I know that some of the questions we haven't been addressed, but I think this is the opportunity for us. Okay. Let me share. So this will be my closing remark right now. Okay, thank you very much. This is the second year that we work closely with LPPM, ITP for the World Environmental Day with ACS publications. The purpose of doing it, we want to make it is from the initiative from the ACS publications, being we have been doing a lot more activity. We do it in April, the World Earth Day, we call it. We work closely with the local chapters. And for this round, we work closely with LPPM ITP for the world environmental issue. And our this year theme is for air pollution. That's why we invite Prof. Choi to share with us, okay, what will be the scientific community sharing in this part of the sessions. So I know everyone have the different expectation. It's a very wide topic when we're looking into the air pollution. And we have a sharing from Prof. Choi more toward the engineering perspective on this issue. And from Dr. Windy itself, for her session is more toward what will be the key concerns, okay, from the regional issue that we encounter. I know that will be more to share with yours. This is the second year that we're working closely on this event. And let me share my slide for today. Just hold on, yeah. I just would like to share with you, being a society publishers and also society by itself, we do have the content provide for the research, okay, to fulfill the needs. At the same time, we try to connect from the individual, from the scientific community to the country perspective to look into how we're going to do our part of the role. Yeah, so being from the ACS publication, I want to share with you about the content that we'll be able to assure. You'll be able to reach out to all this kind of authority information through your library. So I would like to thank for the library also join us, okay, because this is a content provide for the researcher and also for the student to learn and also for teaching sessions. At the same time, you see our expansion of our collections. ACS started with chemistry. So most of our content collection or the initial state is from the chemistry, but we also see the expansion for the environmental science collections. From here, you see the expansion for the environmental science and technology with the great impact factor being accumulated. And also we have the ES&T letters and ACS ES&T engineering and ACS ES&T water This is two new journals. We just launched it in the 2021. I believe it takes time to get the impact factor. Within 2 years, we assure this will be the journals will be focusing very much on the environmental science and technology, very specific into the engineering area and also very specific into the water area. So from the question that from the floor asking, okay, whether it's a discount for this will be on the open access. It's a slightly different approach of the publishing models. At the same time, for the existing collections, we provide the very specific virtual issue related to some of the key environmental and science technology area. And we also have the content from the book sessions. You'll be able to find the information that related to your research from the platform provided from the library. So this is the ebook content that we have. At the same time, we also have the most imaging topic. We'll be able to share it with you in our ACS in Focus. This is a collection for the short reading. It's a new topic for the T-zone learning so that people are able to pick up some of the new knowledge. And in terms of the writing and writings, articles, or submit your assignments, ACS Guide to Scholarly Communication will be another content that you'll be able to use. Okay, I would like to encourage you, that will be a QR code. This is a ACS Insight newsletter. We regularly pull out what will be the latest news about this region, share with the scientific community. Feel free to join us for these sessions. And I would like to inform all the participants, if you fill up the link, you'll be able to receive the certificate of attendees by the end of the sessions. And I would like to thank the organizer committee, Dr. Rino, the team, Maha, Karina, and also our moderator, Dr. Arina, and our two speaker sessions for make this event successful. And I would like to thank you everyone for attending these sessions. I would like to continue to to engage with you for the SCS activity that we continue to organize and reach out to you. Okay, without further delay, I would like to close for today's sessions. Thank you very much for attending our today virtual event. Thank you.
Thank you, Ms. Mandy, for closing remarks. Distinguished guests, ladies and gentlemen, ITB ACS Virtual Talk and Pollution, the Silent Killer has come to an end. Thank you for your dearest attention and participation. Good afternoon and see you on the next minute.
Thank you very much. Have a good day.
Thank you, Ms. Mandy. Great collaboration. Thank you, everyone.
Thank you. Bye.
For material, can share in the chat box.